Hey, welcome back. In the previous lecture, we executed an undefined instruction and then analyzed the stack frame to understand the location of the instruction which caused the fault. Let's consider one more example, divide by 0, and again, let's analyze the stack frame to pinpoint the instruction location in the program which causes the fault. Same thing we are going to do, but let's trap the processor to raise divide by 0 exception. So I'm in the project now. Create one more source file here. Let me right click, new source file. Let me call it as main1.c. Let me just disable this main.c. I'm going to right click, go to properties, build, and I'm going to click exclude resource from build. And let me copy all this code into main1.c. Here we are going to trap the processor for divide by 0 exception. This will be same. I'm going to remove all these codes, and this code will be same to analyze the stack frame, and this code will be same, no changes here. Second step would be enable divide by 0 trap. How do you do this? To do this, again, let's go to the system control block, and here we have to check the register configuration and control register on page 4. Here you have to check configuration and control register, and the address is this one. Let's copy that address, uint32 underscore tpccr. Let's create a pointer is equal to uint32 underscore t star and this address, and let's go to this, and in this register you have to enable the fourth bit. The fourth bit says that divide by 0 trap. If it is 1, then trap divide by 0. Enables faulting or halting when the processor executes an sdiv or udiv instruction with a divisor of 0. Let's enable the fourth bit, 1 shifted by 4. And after that, let's implement one function, void function divide. Let's say int x, int y, and we can type return x divided by y. So let me give this as int here. Let's call this function from here, attempt to divide by 0. So I'm going to do 10 divided by 0. Let's see what happens, and let's go to the debug mode, and let's terminate and relaunch. Let's start this, and let's keep a break pointer here, and let's run. Here is a trap. The exception is triggered, and let's print all the details. Look at the value of UFSR. It is now changed 200. What does that mean? Go to the UFSR. Here it is. This bit is set now. Divide by 0 usage fault. Run, and let's print the content of the stack frame. How do you pinpoint the problem? You have to just analyze PC and LR here. When the exception happened, PC was at this address. Just copy this address and analyze in your list file. So let's go to the list file and let's search for that 800029E 29E. Here it is. The instruction was sdiv, isn't it? The fault happened at this location, and that belongs to function divide. And what is sdiv? Let's explore that. I'm going to copy and paste sdiv here. Here is a guide for SDiv. Let's explore that. And SDiv is sign divide, and its syntax is: this is a destination register, Rn is register holding the value to be divided. That means in our case, if you compare this with SDiv, then R2 must be holding the value to be divided. R2 is A, that's correct, 10. We are passing 10, isn't it? So where is that? Here it is. We are passing 10. R2 is holding the value to be divided. That's correct. And R3. What is R3? That is RM. Is a register holding the divisor. From this stack frame, we can see that divisor is 0. That is attempt to divide R2 by R3. That's a problem. And we know the location which we got from the PC. This was the location. That's how you can analyze things if some exception is triggered in your code. And the same thing is also shown by the fault analyzer. You can go to the fault analyzer here, and it says that attempt to perform division by 0, and here it is. The stack frame is also captured by the fault analyzer. So you can try once again. Here it is. I just reset and let me run. Here it is. The fault analyzer also captures the stack frame of the thread mode code, which is stacked into the stack memory. That's how you can analyze the fault. And remember that if we don't enable usage fault here, then what happens? It will be escalated to hard fault. You can check that. I just disabled usage fault here. And let me retry. Let me run, and here it is. The exception is escalated to hard fault since the usage fault was disabled, and the fault analyzer says that this is a forced one, that is the escalated one, and the reason is this one. And also there are some fault address information registers. These registers contain address of the location that generated the fault. I would suggest you to explore these two registers, MMFAR, that is memory managed fault address register, and BFAR, that give you bus fault address register. These registers will reveal the address of the location that generated the fault. In summary, you have to follow a couple of points in order to report the error when fault happens. You can implement the handler, which takes some remedial actions, implement a user callback to report errors. For example, in this case, you can call a user callback from the usage fault handler to indicate an error, or you can reset the microcontroller or processor. If it is OS environment, the task that triggered the fault can be terminated and restarted. You can report the fault status register and fault address register values, and you can report additional information from stack through the debug interface such as printf. So with that note, I would like to end this lecture, and I'll see you in the next lecture.